So, let's say we have 12.6 grams of lead. And we want to figure out, using this equality here, this many grams equals that many centimeters. We're going to use that to figure out how many, or what the volume we want to find out what the volume is. If you want to make a little note to yourself, you could say something like this: clue. This might help you in taking notes in the future. Clue: per and Rn can mean equals. Okay, that's something that might help you later. Does that make sense? That's what I said a minute ago. All right. So sometimes you'll hear me say, this might help you if you know this. You might want to just write it down for yourself. And just call it a clue or call it a tip or something. Okay? Put it in the corner of your notes or something where you'll find it, and you can use it to help you remember how to do things later. All right. So let's see. We have two things that are equal in this problem, right? What are the two things that are equal in this problem? Okay, this many grams and 1 cubic centimeter. I want to write it out mathematically because that helps to set up a problem, our problems in here, okay? So what we're going to simply say is 11.3437 grams of lead equals 1. I like milliliters. And milliliters is the same with cubic centimeters, right? Yeah. I don't like milliliters. How about that? Milliliters of what? Lead. Remember earlier in this week I said that sometimes you always have to write units of measurement when they go with a number, and you also have to write the species. I said this earlier, but I didn't tell you what it was about. The species, when it also applies, well, this is one case where it applies. These measurements apply to lead. It only applies to lead. Okay, only lead has this density. Okay. So that's an equality statement. And anytime you're given a conversion problem, and we do a lot of conversion problems in here, anytime you're doing a conversion problem, you have to write out the equality statement. And the only reason I have you do that, you probably won't have to do that in any other class after this one, but if you do it over and over and over again in here, it'll be solid. Conversions won't be a problem for you from here on out. Does that make sense? Okay. So always, always, always you're required to write the equality statement if there is one. Got it? Got it? All right, like I see those heads go up and down like that. If I see it like this, I need to ask the question, try to figure out what to do. Okay? Try to help you out. All right. Now then, if that's our equality statement, then those two numbers will be used in a conversion unit. I need to also interpret this problem to find out what our starting amount or given amount is. All right, those are a couple of key phrases. Starting amounts and given amounts are what you start with in a problem. Okay? Starting amounts or given amounts are what you start with in the problem. Okay? It's the measured amount of something. All right? Do we have a measured amount or a given amount or a starting amount of some stuff in this problem? What is it? What? The grams. I got grams in two places. Okay? What's your question? Okay. Well, look at the problem. Everybody look at the problem. Is there a starting amount in this problem? What is it? 12.6 grams of lead. You got to say what it is, okay? Because that's important in here. All right. So here's the thing: starting amounts always go in a fraction over 1. When you're doing the math, starting amounts go in a fraction over 1. All right? So it's just 12.6 grams of lead. I'm going to put it over the number 1. Did I change the amount by doing that? No, it's the same thing, right? It just helps us to keep everything aligned. And that's what I want to do is neatness counts a lot in math in here. It'll help you get the answers right if you keep everything kind of neat. For some of you, that's easy. Some of you write real neat, you know, detail. Some of us are sloppy writers, okay? Me, I'm included. I have to work hard to write so you can even read it, all right? Now, here's the cool part. Here's the dimensional analysis. What I want to do in this problem is I want to find the volume, okay? I'm going to try to get rid of, just like I got rid of x's up here, I want to try to get rid of grams. How do I write an equality statement using this so I can get rid of grams? Well, not the 12.6 on the bottom, but I want to put this on the bottom. Wow, you guys are sharp. I ask that question sometimes and everybody goes, huh? That's great. So we're going to put that on the bottom. And to build an equality statement that equals 1, I need to put the other side of the equality statement on the top. Okay? So the 1 milliliter of lead goes on the top. So this fraction is equal to, two sides are equal here, put them in a fraction, that right there is equal to what? 1. So what this is going to let me do is change how I measure something without changing the amount. And that's a conversion. I'm changing how it's being measured, what units of measurement I'm using without changing the amount. Okay, that's what a conversion is. Somebody had a question.
Oh, I was going to ask, was that 12.6 where it's placed on the equation thing? Is that always going to be where the starting amount would be?
In this class, I can't think off the top of my head of any case where the starting amounts do not go over 1. They always go over 1. Okay? There are some, later in the semester, about 2/3 of the way through, there are some problems where we have to put 1 over something, but that's not because that's not from a starting amount. Alright? Alright. Now, like x's and y's, units and species can cancel. Can you see anything I can cancel? Grams, yeah, like x's and y's. Anything else? PB can cancel. There we go. When I'm done, I will have milliliters of lead, and what am I looking for? Volume of lead, and that measures volume, doesn't it? This is the basic idea behind dimensional analysis. Now we just got to do the math. Got to put it on a calculator. If you have a calculator, get it out. If you have a cell phone with a calculator on it, I'll let you use it today. I can't let you use cell phone calculators on the test because it's too easy to snap a picture of the test and send it to somebody else and help them cheat. Can't do that. But, you know, for this stuff, it's fine today. Okay? All right. So help me out here. Let's go back up here and look. What mathematical operation do I need to solve this problem? Well, I can multiply this times 1. That's true. Okay? And get the same number, don't I? I can multiply this times 1 and get the same number. I could just, remember up here where we just went ahead and divided and canceled here? I can also divide here. That makes sense? I can just take this number and divide by that number and get an answer. Because the 1s don't change anything. Right? Multiplication by 1 and division by 1 doesn't change anything. If I'm losing you now, say so. I don't want to leave anybody in the dust here because some people are catching on hurry and some people are kind of still grasping a little bit. That's okay. All right? Everybody has strengths and everybody has weaknesses. Okay? Is everybody okay with where we are?
Yeah.
All right. So we just want to take this number and divide by this number. Okay? So if you got your calculator, let's practice. You should always practice every problem because it really helps you when you get to the test. You're really good at it. You want to divide by 11.3437. Okay? Let's write that whole number down. Does your calculator only say 1.1 or does it have more numbers? Alright, so 1.1107 486 9751. Now yours doesn't have to have that many digits, okay? You don't want to stop at just 2 digits, but you want to put down every digit you have on your calculator. Now if your calculator is set up to round off automatically, we want to change your calculator so it won't do that. We want to put all the digits down, okay? So we can practice learning how to round properly. Sometimes calculators don't do what we want them to do, all right? So you got to know how to do it for yourself to know if your calculator is giving you a reasonable answer. All that just to figure out how to round off. Okay, you ready? No, I'll give you a minute then. Okay. All right. Now here's the rule in multiplication. Well, let me give you the big rule first, okay? And I think I've already told you this, but just to make sure, I'm going to remind you of the big concept behind all this rounding for significant digits, okay? The big concept is, let's see, I'll slide it up here. Your final answer can only be as precise as the least precise measurement. And the problem. Okay? That's the big concept. Alright, now we're at the point now where the math is kind of done. We're trying to figure out significant digits, okay? So the rules I'm talking about here are about finding the correct number of significant digits for our answer in multiplication and division. Alright?